So, in the last example of our previous video, we saw that the trinomial had a leading coefficient that was a negative number, and we don't like negative leading coefficients. So in order to factor that first, we needed to pull out a factor of -1. It will also be the case that if A, B, and C do not have a greatest common factor of 1, we're going to need to factor out the greatest common factor from all three before we can go ahead and factor the trinomial. So let's take a look at a couple of examples. So what we need to do first is factor out the greatest common factor, and then we can factor the remaining trinomial accordingly. So here I have 16y cubed minus 32y squared minus 48y. So we can see these all have a factor of y we're going to need to pull out. Now, you may need to make some factor trees or go back and review how to find the greatest common factor, but you'll find that the greatest common factor of 16, 32, and 48 is actually going to be 16. 16 times 2 is 32. 16 times 3 is 48. So we're going to pull out a factor of 16y. That's going to leave me with y squared minus 2y minus 3. So now I can factor this remaining trinomial by finding the factors of AC that add up to B. And now we have that A is 1, B is -2, and C is -3. So I need to find the factors of AC, which in this case is 1 times -3, so -3, that add up to B, which is -2. So let's take a look at some factors of -3. So the first thing I thought of was -3 times 1. -3 times 1 is -3, and -3 plus 1 is going to give us a -2. Now, this is really great because our leading coefficient A is a 1. So we can use a shortcut. I know that this is going to pull apart to y minus 3 times y plus 1. So my final answer, I'm going to label this with an A, is going to be 16y, don't forget that first greatest common factor we factored out, times y minus 3 times y plus 1. And remember, we can do this because our leading coefficient A was a 1, and I was able to find the factors of -3, so AC, that add up to B, which is -2. So this is our final answer for this problem. Next, I have -3x squared plus 16x plus 12. So I can look through and see, okay, this doesn't have a factor of x, so that I couldn't pull out an x. 16 is not divisible by 3, but I do have a leading term that is negative, and we don't want a negative leading term. So let's go ahead and factor out this -1. That'll leave me with -1 times 3x squared plus 16x. Now wait, I made a mistake here, right? I pulled out a factor of -1, so I need to switch the sign. So instead of plus, it's going to be minus 16x minus 12x, because when we pull out that negative, it changes the sign. Now, in this example, I do not have a leading coefficient of 1. My new A is 3, my B is -16, and my C is -12. So I need to find the factors of AC that add up to B. AC in this case is 3 times negative 12. That's going to give me a negative 36. And I need to find the factors of 36 that add up to negative 16. So we need to go ahead and look at some factors. I know that negative 36 is going to be negative 6 times 6. Well, negative 6 plus 6 equals 0. Not quite. I see it's an even number, right? So I could divide it by 2. So I could have negative 2 times 18. Negative 2 plus 18 is a positive 16. Okay, we're close. I need this b to be negative. So I'm going to go ahead and have a positive 2 times a negative 18. That adds up to negative 16. Now I can rewrite the factors of my middle term. I can rewrite this middle term as 2x minus 18x. Remember, we don't want to forget the factor we pulled out before. So now I have negative 1 times 3x squared plus a 2x minus 18x minus 12. Now I have a 4-term polynomial I can factor by grouping. Okay, so let's break out some grouping symbols. I've got 3x squared plus 2x. I don't like a negative leading coefficient. We'll write that plus this. Okay, so I have my negative 1 on the outside. Now I look, what's the greatest common factor of 3x squared and 2x? That's going to just be x. So I pull out a factor of x. That leaves me with 3x plus 2. Next, I have negative 18x minus 12. The greatest common factor of negative 18 and negative 12 is going to be a negative 6. So this is negative 6 times 3x plus 2. All right, I know I factored correctly because these two are the same. So I go ahead, I won't forget that negative on the outside. I'm just going to write it as a negative now as opposed to a negative 1. That leaves me with x minus 6 times 3x plus 2. So here we have our fully factored trinomial, remembering to pull out that negative first. For our final example, let's take a look. I have 8y cubed minus 12y squared minus 4y. I can see that these all have a factor of y I'm going to have to pull out. But let's take a look at those coefficients. I have 8, 12, and 4. The greatest common factor of 8, 12, and 4 is going to be 4. So if I pull out a factor of 4y, that leaves me with 2y squared minus 3y minus 1. So now I have pulled out the greatest common factor and I'm left with a trinomial. And I need to find what are the greatest common factors of A, C that add up to B. A is 2, B is negative 3. I don't think that helped. And C is a negative 1. So AC in this case is going to be 2 times negative 1, which is negative 2. So I need to find some factors of negative 2 that add up to negative 3. Luckily for us, negative 2 is prime. It doesn't have a ton of factors. So I have negative 2 times 1 and negative 1 times 2. Okay, negative 1 plus 1 equals negative 1. Negative 1 plus 2 gives us a positive 1. So there are no factors of AC that add up to B. So this right here is prime. That means I can't break it up into any smaller pieces. So now we could just have this as our final answer. Once we've pulled out the greatest common factor, if the remaining trinomial is prime, we're done.